Hi there and welcome to Journey Through to the Centre of the Earth. This is Activity 3 where we're going to be looking at igneous rock with year 8s. Okay, now basically there are three types of rocks which are produced on the Earth's planet. They are igneous, sedimentary and metamorphic. Now igneous rock is shown in red here. Basically it's cooled lava. Then we've got sedimentary rock, for example Ayers Rock, and metamorphic rock, which is something like quartzite. And there's a photo here of one of the new territories. Okay, so what is igneous rock? Well, there are two main types of igneous rock. There's extrusive igneous rock and intrusive igneous rock. And it's all down to the process of their cooling. Now, extrusive means that it is cooled on the outside surface of the planet, whereas intrusive, by its name, meaning that it's cooled on the inside of the Earth's planet or the Earth's crust. Okay, so let's look at extrusive rock first. Now, if you look at the picture down below, you can see an example of extrusive rock beginning to cool. This is a lava flow in Hawaii, and you can see it's cooling on the surface of the rock as it's crashing into the sea. It cools incredibly quickly. Now, because it cools incredibly quickly, what it does is it doesn't allow any crystals to form. Now, crystalline structures are what gives a rock its solid and hard structure. The more crystalline, or the better the crystals realign, the harder the rock is going to be. As a result, extrusive igneous rock tends to be quite brittle, quite soft. Now, maybe we can't break them up with our bare hands, but if you took a hammer and a chisel to it, you wouldn't have a major problem actually breaking it up. You take something like the mineral diamond. Diamond is highly crystalline, which means it cools very, very slowly over a huge amount of time. And the result is it is incredibly hard. To actually split a diamond is not the easiest, hence that's why they're firstly very expensive, because they're very rare, but also because it's hard to cut and polish them. Okay, so what we need to understand is extrusive igneous rock cools incredibly quickly. As a result, it becomes brittle. You'll find that there are air holes which are formed as the gas tries to move its way up through the actual lava to the surface as it begins to cool. Sometimes it can cool so quickly the gas isn't able to form through it, and it just produces a very glassy substance, very black glassy substance, such as obsidian, and we'll look at obsidian later. Okay, now here's an example of intrusive rock. Now intrusive rock is the opposite. It's going to cool very, very slowly on the inside the Earth's crust. Now how it works is that channels are formed in cracks in the Earth's crust due to the movement of the crust, and lava can actually move its way up through these cracks, but it can't get out to the surface. And what happens is the surrounding rock acts like an insulator. So it keeps the rock hot, and it gives the opportunity for the crystals to realign. And because they are able to align themselves, the result is they can become very hard. And as a result, intrusive rock tends to be a darn sight harder than any of the extrusive rock. And an example of this is the bread knife formations, which are formed in the Warrumbungle Mountains in New South Wales. And there's a photo below. And what you can see is you get these very hard rock sticking up amongst very soft rock. And this is because of the cracks which are formed in the Earth's crust, allowing that lava to flow up and then cool very, very, very slowly. And as I've put in that third bullet point, they're able to realign, and as a result the rock is incredibly strong. Now there are two main areas where the intrusive rock can actually form, and that's through areas of dikes and sills. Now basically a dike is a vertical column, whereas a sill is a horizontal column. Now you can see in the picture on the left hand side here, the red circle denotes the dike, and you can see that lovely grey vertical area going up through the rock. Now it hasn't been able to penetrate all the way up through the mountain, but you can see that the rock is actually formed due to, or you get a different type of rock forming due to the lava flowing up through that vertical section. Cracks then will have occurred on between layers of rock, and hence that's why we get the sills, which is denoted by the yellow circle or ellipse that you've got in that diagram. The second diagram at the bottom on the right hand side again shows you your dikes and your sills, and the batholith is just basically a reserve of lava flow which is beneath it. Now what will happen is over time, because they cool really slowly, the outside rock is very, very soft, so that will be weathered and eroded away very, very easily, whereas you've got your intrusive rock, which is nice and hard and crystalline, that's going to remain, and hence that's how you get the bread knife and the Warren bungles. Okay, so hopefully that makes sense with respect to your dikes and sills. So what we'll do now is just run through a couple of, or 6 different examples of igneous rocks, which will help you understand and be able to be used in some of your understanding as to how those rocks come about. Now the first one, the most classic one, is basalt. Now basalt, it comes in a variety of different forms, but again it's an extrusive rock. It's formed from cooled lava. Now sometimes you'll find basalt with holes in it, sometimes you'll find it with as a darker color, sometimes it's black, depending on the area that it's come from. But the crystals are very, very small, which means that yes, it can cool almost like a slight intrusive rock, but it's only because the outside crust forms very, very quickly, and then the rock inside basically cools a little slower, and as a result it can make tiny crystals, but they're not very big. So as a result, it's still quite soft. Now the next one below is volcanic tuff. Now that is formed when the air comes up through the lava, and sometimes you'll see lava flows which are bubbling. Now as it bubbles and sends out little bits of rock, they cool very, very slowly and form a crust on the outside, and what you get is this tough, not tough, but crumbly rock because of all the air bubbles which is formed. So it's basically formed by what's known as volcanic ash, and again, very, very quick cooling because it's only very small. There's not a lot of heat that can be that can be held within it because it's so small. Pumice is probably one of the classic ones that you've learned. Pumice looks like a rock. You pick it up and it's almost as light as a feather, and the reason why this is because of the huge amount of air bubbles which form around it. Now if you ever go to Pompeii in Rome, where there was a massive explosion from Mount Vesuvius, there are actually places where you'll find people actually encased in pumice, because basically it comes from the smoke and the debris and the dust which all forms together. It's still incredibly hot, gets compacted, but the air moves through it, so it gets that rock-like formation, and it can encase itself around objects. So pumice, very light, maybe something that you might use to remove dead skin. Sometimes you'll find pumice and it can be used to remove dead skin because it's slightly rough, but it's incredibly light. And finally we've got obsidian, again another intrusive, so that should be extrusive rock. It's an extrusive rock, which basically means that it's been cooled so quickly that no crystals can form, and as a result it becomes that black glassy rock, which can yeah, it looks really, really nice. So make sure you change on that one. It's not intrusive there, it should be extrusive, and apologies for that mistake there. Now 2 examples of intrusive rock are granite and rhyolite. Now granite is formed, as we said, either in a dike or a sill, doesn't matter which. You will get very defined crystals which are formed in the granite because it cools incredibly slowly. Again, the different types of colors that you see within are due to the types of minerals which make up that granite rock. Same with the rhyolite below. As it says at the bottom there, comes from more viscous lava. And you know, it's funny, we talk about viscous lava or lava which is runny. Different parts of the world, different volcanoes will have different types of lava because they're fed from different areas of the planet crust. And next year in year 9 we'll look at how that comes about. But what you'll find is you'll either get quite runny lava, quite thick lava, and because of the minerals that it moves through will determine the type of rock that's been produced. The key element here is that the intrusive rock basically is very hard because you've got very good crystalline structures which are formed within during its cooling. So remember, these 2 types of rocks will be cooled either in dikes or sills. So that basically gives you a rough insight into igneous rock. So thank you for watching. Join me again and we'll look at the other 2 types of rocks. Thanks for watching.